Neural Frame Rate Upscaling, or NFRU, is an ARM neural graphics technology that can double the perceived frame rate of a mobile game. It allows a game that's running at 30 frames per second to be rendered at the visual equivalent of up to 60 FPS. Or, for a game that's already running at 60 frames per second, NFRU can increase the visual frame rate even further, up to 120 FPS, creating incredibly smooth, fluid visuals for a fraction of the native rendering cost. This creates a huge amount of performance flexibility, allowing you to choose between a smoother visual experience or redistributing your game's existing resources to unlock other features, such as improved graphics settings, better thermal efficiency, or advanced rendering modes that might have otherwise been impossible to use, such as ray trace lighting and shadows, all without any noticeable drop in frame rate. So how does it work? NFRU compares the data between two real frames to create a new synthetic frame between them, adding visual information where it didn't previously exist. It works by generating candidate frames, interpolations of the movement between the previous and current frames that are based on motion vectors to account for known geometry movement, and optical flow to account for pixel level changes, such as lighting and shadows, that traditional motion vectors cannot represent. The result is 4 possible interpretations of the intermediate frame, built using color and depth from each native frame that's warped using either motion vectors or optical flow to create a representation of what could be in the new generated frame. This information is then passed to the neural network, along with the added context of depth and motion, to decide which version is likely to be the most accurate at each position on the screen. For example, the network may blend towards motion vectors for pure object movement, or it may choose optical flow-based candidates where lighting and shadows have changed. Areas of disocclusion, calculated using geometry-based motion, reveal missing information, hinting to the network that it may need to rely more heavily on optical flow candidates than motion vectors in those areas. The end result is a per-pixel weighted blend of the 4 possible candidates that can be used to construct an accurate final image that's highly representative of an equivalent native render, which, when interleaved with real frames, results in a perceived doubling of the game's base frame rate with minimal artifacts and minimal latency. When a real frame is rendered, NFRU uses the information from that frame and from the previous real frame to generate the new synthetic one. This happens after the real frame is rendered, but before it's displayed, allowing the generated frame to be presented in place of the real one, which is delayed until the next available v-blank, adding a frame of latency at the new upsampled rate, or half a frame of added time between input and response when compared to the game's native update loop, resulting in a meaningful increase in the game's visual frame rate in return for a minimal amount of added latency. NFRU is available now as part of the ARM Neural Graphics Development Kit, which includes the NFRU Unreal Engine plugin, the Vulkan ML SDK, and is designed for upcoming Android devices using ARM neural accelerators. Visit developer.arm.com and try it for yourself today.